Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Cbse board exam, we'll be discussing the sample paper published by Cbse for the year 2021. The mathematics sample paper contains various sections, 5 sections in fact, and today we'll be discussing section 3 of the same paper. This is the 6th video in this series. Now let's start this episode with question number 26 of the sample paper. This question is asking us to find the area of the parallelogram whose one side and a diagonal are represented by co-initial vectors I cap minus k cap plus j cap plus k cap and 4i cap plus 5k cap respectively. How do we start solving this question? Well, let's consider this as a side A bar, and let's consider this as 4i cap plus 0j cap plus 5k cap as the vector D, which is a diagonal. Now, when we draw a diagram for a parallelogram described as such, let's redraw this again. So let's say we have a parallelogram made up of vectors, and let's consider this as vector A. This is another side. Let's consider this as vector B, and the co-initial diagonal as vector D. So we know the vectors A and D. We just don't know the value of vector B. However, according to parallelogram law of vectors, parallelogram law of vector addition, the diagonal D bar is equal to A bar plus B bar. Therefore, the vector B is equal to vector D minus vector A. Now let's start subtracting these two. So that is 4i plus 0j plus 5k minus I plus j minus k. I've just multiplied minus 1 to all of my components. 4 minus 1 is 3i, plus 0 plus 1 is 1j, and 5 minus 1 is 4k. So the vector B is equal to 3i cap plus j cap plus 4k cap. Now, how do we find the area of this parallelogram? The area of a parallelogram can be represented as the modulus of the cross product of the vectors A and B. So we need to find the cross product of A and B. So A cross B is equal to the determinant. In the first row, we have I cap, j cap, and k cap. In the second row, we have the xyz components of vector A, that is 1, minus 1, and 1. In the third row, we have the same components for vector B, that is 3, 1, and 4. Now let's start expanding this along row 1. So we have I cap into minus 1 times 4, minus 1 times 1, minus j cap into 1 times 4 minus 3 times 1 plus k cap 1 times 1 minus 3 times of minus 1. The products inside the brackets will be minus 5, 1, and 4 respectively. So now we have minus 5i cap minus j cap plus 4k cap as the cross product of A and B. Now let's find the area of the parallelogram, which is the modulus of A cross B. So that means the modulus of this vector, that is equal to the square. I mean, that's the square root of the sum of squares of each of the components. What that means, it will be minus 5 the whole square plus minus 1 the whole square plus 4 square the whole root. That'll be 25 plus 1 plus 16 the whole root, which is equal to root 42 square units. Since we're talking about area, we should end this in square units. Now, the marking scheme for this one is finding vector b will earn you half mark. Doing the cross product will earn you 1 mark. And writing out this answer, root 42, will earn you half marks. Now let's look at question number 27. Find the vector equation of the plane that passes through the point 1, 0, 0 and contains the line r bar equals lambda j cap. How do we solve this question? To solve this question, let the normal vector of the plane be represented as some n bar. Now, we all know that the equation of a plane passing through any point is r bar minus a bar times n bar equals 0. Here, we need to find the equation of the plane passing through 1, 0, 0. Now, 1, 0, 0 has only one component along x-axis, so therefore this is just I cap. So the equation of the plane will be r bar minus I cap times dot n bar equals 0. This is our equation 1, and this step will also fetch you 1 mark. Now, remember that in the question, the plane contains the line r bar equals lambda j cap. So the line r bar equals lambda j cap is perpendicular to the normal vector of the plane. So therefore, you can say that j cap cross n bar, j cap dot n bar will be equal to 0. J cap dot n bar, that is the dot product of j cap and n bar, is equal to 0. This means that n bar is perpendicular to j cap, so it's just the same thing. Now what are we going to do is, we also know that here the plane contains the point 1, 0, 0, and since the point 0, 0, 0 is also coplanar with 1, 0, 0, the plane also contains the point 0, 0, 0. So therefore, we will put r bar equals 0 in equation 1. So that means 0 minus I cap times n bar is equal to 0. That means minus I cap times n bar is equal to 0. So I cap dot n bar is equal to 0. This means that the vector n is perpendicular to I cap. Now, vector n is both perpendicular to j cap and I cap. Therefore, vector n must be equal to k cap. So now we put n bar equals k cap in equation 1. So therefore, this becomes r bar minus I cap times k cap equals 0. So that means we have r bar dot k cap minus I cap dot k cap is equal to 0. I cap dot k cap is already 0, so r bar dot k cap is equal to 0. This is the final equation. And the step from n bar equals k cap till r bar dot k cap equals 0 will fetch you 1 mark. So the first part of finding the equation through the plane and finding the fact that n bar equals k cap and the subsequent final equation will fetch you both the marks. Now let's look at question number 28. A refrigerator box contains 2 milk chocolates and 4 dark chocolates. 2 chocolates are drawn at random. Find the probability distribution of the number of milk chocolates. What is the most likely outcome? So one thing to note is that since we're taking chocolate, you know that when you take chocolate out, you don't replace it back, you eat it. So therefore, the chosen chocolate is not replaced. Another thing is that since we have 2 milk chocolates and 4 dark chocolates, and we need to find the probability of find the probability of chocolates taken at random, 2 chocolates taken at random, that will be P of x. Now the value of x can be 0, 1, or 2. That means you can choose all dark chocolates, 1 milk and 1 dark chocolates, or 2 milk chocolates. The value of x is 0, 1, and 2. Let's find out each of the probabilities. P of x equals 0 means no milk chocolates. That means you have 4 dark chocolates and you can choose one of them from the total probability of 6. And since the chosen chocolate is not replaced, the second choosing will have 3 dark chocolates among 5. So that means you have 12 by 30 as P of x equals 0. For P of x equals 1, you will have the probability of 1 milk chocolate and 1 dark chocolate. So either the milk can be chosen first or the dark can be chosen first. So it can be 2 by 6 times 4 by 5, or it can be 4 by 6 times 2 by 5. That's why we add those probabilities up. You have 8 by 30 on both sides, so you get a total of 16 by 30 as P of x equals 1. P of x equals 2 means you have 2 milk chocolates, so you only take 2 of them. So that means 2 by 6 times, in the second choosing, it will be 1 by 5. So you have a total of 2 by 30 as the probability of x equals 2. Now we know the value of P of x equals 0, P of x equals 1, and P of x equals 2. We must draw a frequency distribution table. So x, P of x, then we draw 3 columns, 0, 1, and 2. For 0, it's 12 by 30. For 1, it's 16 by 30. And for 2, it'll be 2 divided by 30. Now, as you can see, the highest probability is for P of x equals 1. So choosing 1 dark and 1 milk chocolate is more likely. Now, the steps from P of x equals 0 till the frequency distribution table will fetch you 1.5 marks, and this final step will earn you half marks. And that is how you solve these kinds of questions. Question 28 has an OR question, and this will be the final question of section 3 and also of this video. Given that E and F are independent events such as P of E, sorry, this is not independent. There is no mention of independent events. So we have 2 events, E and F. We have P of E is 0.8, P of F is 0.7, P of E intersection F is 0.6. Our question is to find out P of E bar intersection F bar. E bar means the event that E does not occur, and F bar means the event that F does not occur. Now, P of E bar given F bar can be written using the formula P of E bar intersection F bar divided by P of F bar. Now, P of F bar is easy to find. It's just 1 minus P of F. P of not occurring is 1 minus P of occurring. So that'll be 1 minus 0.7, that is equal to 0.3. P of F bar is equal to 0.3. Now, we need to find the value of P of E bar intersection F bar. E bar intersection F bar can be written down as E union F the whole bar. That can be written as 1 minus P of E union F, which will then be equal to 1 minus, the formula for P of E union F is P of E plus P of F minus P of E intersection F. So P of E bar intersection F bar will now be equal to 1 minus, in the bracket, 0.8 plus 0.7 minus 0.6. 0.8 plus 0.7 is 1.5. 1.5 minus 0.6 is equal to 0.9. So P of E bar intersection F bar is 0.1. So the probability of E bar given F bar will now be equal to 0.1 divided by 0.3. Multiplying by 10 on both sides, you will get 1 by 3 as the probability of E bar given F bar. So this formula will fetch you half marks. Finding P of E bar intersection F bar will fetch you 1 mark, and the final answer will fetch you half marks. And that is the marks distribution for this question. Now, this concludes section 3 of the sample paper for the year 2021. We hope you found this video interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.